Very good evening, friends. Hope so. I am audible. Yeah. Right, my dear friends. This is the intense revision program, class number 4. I believe that already you got the topics what exactly we'll be discussing about. So in today's class, we'll try to complete the rest of climatology. That is, we have to talk about this mechanism of monsoon. And since this year is a year of El Nino, I feel that, say, for example, monsoon again this year becomes very important. Okay. And apart from that, we'll also talk about El Nino, La Nina, Indian Ocean dipole, positive and negative phase, possibly. Right. Then we'll also talk about the climatic regions of the world. Again, for preliminary examination, this climatic region is one very important topic that we have to discuss about. It means, on an average, once in 2 years, we get one question from this climatic classification as such. Then we'll be talking about the features of the ocean. We'll be talking about the ocean water property, and we may also talk about this, excuse me, yeah, we were discussing about somewhere, as I said, we'll be discussing about the ocean water property, the ocean water movement, and the oceanic features as such, right? So one by one, we'll just take it forward. So I'll just start with the, okay, this monsoon as a mechanism. And before that, 21st May, we have a special marathon for current affairs, where the complete 1 years of current affairs, the very important events will be discussed, will be somewhere. We'll be trying to cover those areas as such. Kindly, right, say for example, try to attend it. That'll be very useful for you, right? Now, right, my dear friends. Now, starting with monsoon as a mechanism. See, what is this monsoon, right? Somewhere, if I'm just trying to understand monsoon, India itself is a classical example where we experience what? Monsoon. At least we have two monsoon. One, we call them as what? Southwest monsoon, and two, we call them as what? Northeastern monsoon. It means one part of the year I'll be having a wind which will be moving from southwestern direction. Okay, so wind is always named from where exactly it comes from, right? A wind which moves from southwestern direction, you call them as what? Southwestern monsoon. And which wind which comes from northeastern in direction, we call them as what? Northeastern monsoon. Okay, so wind always comes from, right, whichever direction it comes from, accordingly we'll be naming it. And what I experience, what I see here, when I talk about Indian monsoon, somewhere we have a complete reversal of wind that is taking place. 180-degree of reversal is taking place. This reversal of wind is what we call them as what? Monsoon. That's what the definition itself says. The regional and the seasonal reversal of wind. Okay. The regional and seasonal reversal of wind, you call them as what? Monsoon, my dear friends. Okay. We call them as monsoon. Okay. This is, sorry, as I said, the regional and seasonal reversal of wind, you call them as what? Monsoon. So the word reversal is very, very important. Okay, right. Now, one of the things that I should understand, what exactly is this monsoon? See, I know the fact that all these pressure belts will be moving north and south, right? They'll be moving north and south. When I say all the pressure belts, they move north and south. During summers, what happens? Every pressure belt will be moving north. Okay. So when I talk about the month of June, summers of northern hemisphere, every pressure belt will be moving north. And the general shift of these pressure belts may be 5 to 10 degree, right? Say, for example, north of its original location. For example, assuming that when I talk about subtropical high, we have a pressure belt called a subtropical high. Assume that the subtropical high is somewhere placed at subtropical high. Normally, assume it is placed somewhere around 30-degree, right? North latitude. During summers, what happens? It may shift to somewhere around 40-degree latitude. During winters, what happens? It may shift to somewhere around 20-degree north latitude. So during summer and winter, there will be shift of this pressure belts in general. Okay, we'll be having this pressure belts, shift of this pressure belts taking place. Okay, we'll be experiencing the shift of this pressure belts as such. Now, when talk about the shift of this pressure belts, my dear friends. Okay, somewhere I understand every pressure belt, as I said, it will be shifting north during summers and south during winter. So what happens? We have 7 pressure belts total. Totally, we have 7 pressure belts. And every pressure belt, when it shifts north or south, we understand one thing. The shift will be happening within the same hemisphere. For example, when I say, I have just taken the example of the subtropical high. The subtropical high, normally you find it along 30° north, 30 to 35° north. Maybe during summers, peak summers, it may get shifted up till 40° north. Peak winters, it may shift somewhere around 20° north. It means there will be a southward shift. So whatever it is the case, the shift is happening within the same hemisphere. But what happens when I talk about this ITCZ, my dear friends? ITCZ, what is ITCZ? Equatorial low, right? Either you call them as ITCZ or sometimes you call them as what? Equatorial low. Okay, ITCZ or equatorial low, right? Sometimes you also call them as what? Gold drop. They shift. They shift, say for example, north and south, and this shift, my dear friends, this shift, right, is somewhere. Okay, they also shift, as I said, right? But when I talk about ITCZ shifting north and south, my dear friends, the shift of ITCZ during summers, the complete ITCZ or equatorial low may be placed in the northern hemisphere. During winters, this ITCZ may be placed in southern hemisphere as such. Okay. So somewhere we understand that shifting of ITCZ will take place. Now all other, say for example, this pressure belts, the shift will be within the same hemisphere, but ITCZ will be shifting between hemisphere. So ITCZ during summers, my dear friend, summer, completely it will be there in northern hemisphere. During winters, what happens? It will be completely there in southern hemisphere, right? Completely it will be there in southern hemisphere. Okay, that's what somewhere I can see this in diagrammatic representation. Maybe what you find behind my head is a halo. Okay, maybe this green mat is exactly not working. Okay, right. Okay, whatever it is the case, right? Somewhere, what you can see here, the shift of ITs is it. Maybe whatever is visible, I'm just showing you, right? The shift of ITs is what I'm saying, right? During summers, you have this shift of ITs in the northern hemisphere. During winters, what happens? It is getting shifted towards what? Southern hemisphere as such, right? That's what we are, somewhere we see it. Now, what happens? The general shift of ITCZ is somewhere 5 to 10° north of equator. Somewhere it is 5 to 10° north of equator. But what happens? Given the continental size of Asia, there was one exceptional bend of ITCZ is recorded over Indian subcontinent, right? Somewhere, right? It is recorded over Indian subcontinent as such. Okay. Now, when I talk about this exceptional bend, my dear friends, what is the reason for this exceptional bend? The size of Asia, the size of Asia is the reason for this exceptional bend. Okay, because somehow what happens, because of the continental size of Asia, because of the continentality, low pressure gets extended as north as possible. Okay, and this bend is even beyond the Tropic of Cancer, gets extended even beyond Tropic of Cancer, as I was saying. Okay, now what happens once this ITCZ gets shifted north? When it gets completely placed in northern hemisphere, I know that ITCZ is a place where two trade winds will be confluencing with each other. What are the two trade winds? One is southeastern trade, which comes from southern hemisphere, and the northeastern trade, which comes from northern hemisphere. Both will be confluencing at ITCZ. ITCZ normally it will be there in equatorial belt, but this shift is happening because of summer, because sun's vertical rays will be somewhere moving towards what? Tropic of Cancer during summers. Okay. That's the reason, say, for example, why exactly we are experiencing enormous heat nowadays, right? It is all because the sun's vertical rays is moving towards what? The north as such. Okay. That's a, say, for example, the primary reason why exactly we have the shift of this pressure belt which is taking place. Okay. Now, somewhere the point to be noted here, this shift is even beyond the Tropic of Cancer. Again, I have justified why exactly this shift is taking place. Somewhere we have justified it is all because of the continental size of Asia, right? So what I have to understand, once there is an exceptional bend, what happens? The southeastern trade, in order to confluence with the ITCZ, it will be entering northern hemisphere. So what happens as and when it enters the northern hemisphere, the Coriolis effectivity changes. Okay, northern hemisphere, the southern hemisphere, the direction of deflection of Coriolis force is towards the left. Northern hemisphere, it is towards what? The right, my dear friends. Okay, it is towards the right. Okay, it is towards the right. Because of this fact, what happens as and when it enters the northern hemisphere, surpassing, say for example, this equator as such, surpassing the equator, right? I understand the deflection happens towards what? The right. As it gets deflected towards right, the southeastern trade eventually flows as southwest monsoon. So one liner, if you want to remember the southwest monsoon and one liner, very simple. Somewhere I'll put it this way. Southwest monsoon is all about deflected southeastern trade in northern hemisphere. As simple as this, right? It is just a deflected southeastern trade in northern hemisphere. Okay. All right, my dear friends. So somewhere we have an idea that what exactly is southwest monsoon. Again, I'm just telling you, it is just a deflected trade wind of southern hemisphere and northern hemisphere. Okay. Southeastern trade, how exactly it becomes southwestern monsoon just because of the Coriolis deflection. Now, why exactly it is called as advancing monsoon, if you ask me? Because slowly and steadily, as the sun's vertical rays advances towards the north, right? As it advances towards the north, what happens is ITCZ will also shift towards north. So slowly, steadily, this ITCZ will be covering all the, say, for example, the latitudinal extent of this country. That's the reason you call them as what? Advancing monsoon as such. Okay? Right, my dear friends. Now, if I can understand what exactly is southwest monsoon, now comes another question. What is this northeastern monsoon? You call them as a retreating monsoon. So here, the month is very important, right? When exactly I have the southeast monsoon, northeastern monsoon happening, somewhere it starts from mid of September and extends till middle of December. So September, my dear friends, see very carefully if I just look at the dates, very important. See, for example, southwest monsoon in India, somewhere from June to September. Okay. And if you ask me what exactly June is known for, June is known for what? Summer solstice. September is known for what? Equinox. Again, when I talk about northeastern monsoon, my difference, December is known for what? Again, say for example, it is known for winter solstice. So, this is a period when sun's vertical rays once again start shifting towards what? South. By the month of September, what happens, my difference? Sun's vertical rays will be falling over equator. So, what happens? This ITCZ also shifts south. It shifts south. So, by the month of September, my difference is this ITCZ will be falling exactly or somewhere around this equator. Correct? Around this equator. See, ITCZ is very closely associated with thermal equator. Thermal equator. If you ask me what exactly is thermal equator, somewhere around 360 different longitudes are there. All this 360 different longitude, if I just take it one way, every longitude I take, mark the place where exactly I record the maximum temperature. 360 different locations if I'm just marking it. If I connect all the places which is having the maximum temperature, right? That line you may call it as thermal equator. So ITCZ, my dear friends, most of the time, it overlaps with thermal equator. And thermal equator is very closely associated with sun's vertical rays. When sun's vertical rays is moving north or south, thermal equator will also move north or south. Direction is north or south. Okay. But not necessarily that wherever it is moving, it will also move. For example, when I say on June 21st, I know the fact on June 21st, the thermal equator will be falling over Tropic of Cancer. All right, 23.5 degree north, I know. But not necessarily the thermal equator will be also falling over Tropic of Cancer. Not necessarily. Okay, it will be moving north, but not necessarily it will be falling over, say for example, Tropic of Cancer as such. Right? That's what the point is all about. Okay. Right, my friends. Now, northeastern monsoon, once this ITCZ somewhere places itself south of India, what happens? The displaced northeastern trade. See the earlier image, if I'm just showing the earlier image, I'll show you the earlier image. The earlier image, I have the southwest monsoon. Once the southwest monsoon starts flowing over India, the northeastern trade winds gets displaced. Okay. This displaced northeastern trade, my dear friends, will once again start flowing over India. Right? See this. Okay. This northeastern trade, when it starts flowing over India, this is what we call them as what? Northeastern monsoon. Okay. So what is southwest monsoon? Simple one-liner if I'm just taking southwest monsoon. What is southwest monsoon? Southwest monsoon is all about the southeastern trade being deflected and eventually flowing. Or maybe I'll put it this way, deflected southeastern trade in northern hemisphere, I call them as southwest monsoon. Then what is northeastern monsoon? Simple, re-established northeastern trade. See, I have two trade winds. You remember, we have two trade winds. The trade wind of the northern hemisphere, my friends. Trade wind of the northern hemisphere, you remember, trade winds or easterly winds. Easterly winds of northern hemisphere or northeasterly, correct? Similarly, when I talk about southern hemisphere, easterly winds of southern hemisphere is southeasterly, correct? Now read it. Northern hemisphere, what I have is northeastern trade. Southern hemisphere, what I have is southeastern trade. Okay, this much I know, right? So what is southwest monsoon? Southeastern trade getting deflected and flowing over India, southwest monsoon. Then what is northeastern monsoon? Re-established northeastern trade over India is northeastern monsoon. Normal condition is northeastern monsoon. Reversed condition is southwest monsoon. Okay. So why exactly we are having monsoon? It is all because of the shift of pressure belts. Okay. So this is conceptual, my dear friends. Conceptual. Idea is very, very right. Otherwise, idea is very, very simple as such. And one more thing, see, monsoon, nobody has understood monsoon till today. Right? I doubt even monsoon itself would not have its own understanding. Right? That's the reason sarcastically we say that understanding monsoon is something like understanding your life partner throughout your year. Means almost life you may not, right? You may not. I'm not saying that you cannot. I'm saying you may not. Okay. The point what I'm just trying to say, understanding monsoon's nuances, nobody can do it. Even meteorological department with that much of advanced knowledge and techniques, they right. It means exact prediction of that may not be possible. But what we are trying to understand is just the monsoon as a mechanism. What is southwest monsoon? What is northeast monsoon as a mechanism? That's it. And what are the, say, for example, different phenomena which were somewhere which can have its influence in this monsoon, right? Whether it can have its positive influence or it is negative influence. That's what somewhere we'll be trying to identify in that sequence, my dear friends. Now, by default, when I say Indian monsoon, okay, by default, when I say Indian monsoon, this Indian monsoons refers to southwest monsoon. Okay. See, I understand northeastern monsoon is also a monsoon, but why? Simply by default, if I say Indian monsoon, why it means southwest monsoon, I'll tell you. Because when I talk about, say, for example, the southwest significance of the southwest monsoon, my friends. Southwest monsoon covers a 90 percentage of Indian land. 90 percentage of Indian land it covers, right? And not only that, southwest monsoon, my dear friends, nearly brings 75 percentage of annual precipitation. Correct. For example, I'll put it somewhere. If I'm just talking about right, almost whatever is the, say for example, the annual precipitation yield what the entire country, say for example, is experiencing. Southwest monsoon itself brings 3/4 of the demand. 3/4 of the demand. Okay, see, 90 percentage of the land it is covering, and 75 percentage of the precipitation somewhere it brings. It means by default, I should address southwest monsoon as Indian monsoon. Northeastern monsoon do brings precipitation, but only to the limited regions of India. Only to the Coromandel coast and, say, for example, almost the very small coast of northern circles. That is Andhra Pradesh and Tamil Nadu. Okay. Only, say, for example, very limited regions of India as such. Okay. So I believe by default, Indian monsoon means southwest monsoon. Okay. This is one very important understanding. Now here, what is southwest monsoon? Just now I said southwest monsoon is nothing but what? Southeastern trade of southern hemisphere getting deflected. It means to have a successful southwest monsoon, to have a successful Indian monsoon, my dear friend. See, for example, even today, I would say, for example, agriculture may not be the major contributor to the GDP, but still today, when I talk about the persons employed, say, for example, in different sectors, agriculture, right, or the primary sector happens to be the largest sector when it comes to employment as such, right? So, how many people are engaged in, say, for example, different sectors as such, if you ask. Okay. But otherwise, I understand. Say, for example, till today, right, it is nothing wrong in calling our country as basically an agrarian country, right? Because the larger section of the population is dependent on what? Agriculture. And this agriculture itself is dependent on what? This monsoon, southwest monsoon. So, and somewhere we have identified a trend in the past, if not in the, say, for example, recent times. whenever the set targets of the GDP is not achieved, my dear friends, right? Say, for example, we don't have any 5-year plans, right? As of now, we don't have any 5-year plans. If I'm not wrong, the 12th 5-year plan was the last plan what we had. Now, somewhere, generally, we had a trend. Whenever we failed achieving the set targets of the 5-year plans, either the reason will be, say, for example, our country would have, say, for example, engaged in some war with the neighbors. Of course, we have not entered into any war, right? We have just retaliated the neighbor's call as such, right? Right. Whatever it is the case, right? Whenever we had a war, say, for example, that was happening, somewhere we missed the targets in the GDP. And apart from that, whenever this monsoon failed, again, we somewhere we missed our targets in achieving as such. So one thing we understand, monsoon plays a very important role. Monsoon plays a very important role in determining the economic nature and status of the country. In that way, my dear friends, right? Southwest monsoon is a very important monsoon for the larger benefits of the country as such. Now, when I talk about southwest monsoon, to be successful, the southeastern trade of Indian Ocean should be strong. If it is strong, yes, I can have southwest monsoon. But what is very interesting, when I talk about this southeastern trade or the southwest monsoon, right? I understand, say, for example, this wind which comes to India, largely we say that, okay, this comes from Australia, agreed, accepted. Okay. But my dear friends, like an indirect effect, right? Say, for example, it has a continuation or it has the effect, or say, for example, the extended source till Peruvian coast. We had an extension till Peruvian and Chilean coast, my dear friends. It means the wind which comes to India has an indirect extension till South American coast, till South American coast. Okay. So maybe I'll put it this way, right? For example, see, I have some wind. Australia, assume that Australia has high pressure. The Tibetan region will be experiencing a low pressure. So somewhere I understand the wind will start from flowing from Australia and it will be start moving towards what? Indian side as such. Accept. But see, when Australian region experiencing a void, I understand they also have a similar wind moving from Peruvian coast to Australian coast, right? It means the immediate source of southwest monsoon is southeastern trade of Indian Ocean, whereas extended source of southwest monsoon, that is Indian monsoon, is southeastern trade of Pacific Ocean. Okay, that is an indirect extension. Now, what happens, my dear friends? To have a successful southwestern monsoon, two things is needed. Number one, right? Number one, what is needed? We need a very strong or a moderate, not necessarily every time it should be a strong or moderate southeastern trade of Indian Ocean. And not only that, we should also have a strong southeastern trade of Pacific Ocean. Both wind has to be strong enough. Only then southwest monsoon will be successful. Now, what happens here, my friends? Sometimes the southeastern trade of Pacific Ocean gets affected. What is that condition when southeastern trade of Pacific Ocean gets affected? That is the condition we call them as what? El Nino. See, this year El Nino is important because 2018 we had last El Nino. After that, 2023 is that year we are having this El Nino, right? We are going to have this El Nino. Okay. See, they say for example, the impact of El Nino is not much, may not be much somewhere, but still 60 to 70% somewhere we are anticipating the, say for example, the effect of El Nino as such. So, now, for successful Indian monsoon, what is the condition needed? We have an idea. Okay. Now, having said my difference, only thing is that I'm just talking about this El Nino. What is this El Nino? Right? What exactly is El Nino? I'll tell you my difference. See, today's class, towards the end of the class, we'll be talking about this ocean currents. But whenever I talk about any ocean currents in general, any ocean currents, normally you'll be finding one trend. I'll show you, maybe I'll just surpass it, right? Just taking the ocean currents. Today we'll be talking about this ocean currents. Any oceans you take it, my difference. Normally you take any oceans as such. Okay. Normally take any oceans, right? Right, my friends. I was just talking about this, right? Say, for example, ocean currents. Somewhere, any oceans you take it, any oceans I take it, one similarity I find. For example, any gyre circulation, I'll be finding that put yourself in the oceans. The western side of the ocean, I'll be having warm currents, and eastern side of the oceans, I'll be having cold current. Right? We do have an exception, right? Tropical waters, this is normal. Temperate water, slightly it will change. Only the northern basin, small minor currents, there will be a change. But otherwise, largely the logic what I'm saying will be working. In that way, if you're there in Pacific Ocean, eastern side of Australia, that is western side of Pacific Ocean, I have a warm current called as East Australian current. Similarly, right, the eastern side of Pacific Ocean, right, I have a cold current called as Peruvian current. Peruvian current is a cold current. Okay. So if I just take both, my dear friends, if I take both, right, what I understand here, right? For example, normal condition, right? Australian side, eastern side of Australia, I have the influence of East Australian current. And this East Australian current is a warm current. I have an idea. It is a warm current. Okay. Whereas Peruvian coast, I have this cold current called as Peru current. Fine. Now here, when I talk about normal conditions, what happens? Wherever the warm currents happens, there you'll be having a creation of a low pressure. Wherever I have, say, for example, this cold currents influence, I'll be having a high pressure. So once the pressure system is created, right, very easily I'll be having this southeastern trade, right? The southeastern trade of Pacific Ocean becomes what? Very, very strong. This is a normal condition. But what happens? Simple logic. When I talk about warm waters, Australian side I have a warm water. Peruvian coast I have a cold water. Assume that this is Australia. Assume that this is Peru. Australian side I have a warm water. So warm water will be less in density. So this water will rise. The cold water will be more in density, slightly the water will subside. It means between Australian coast and Peruvian coast, you will be having a gradient difference. 11 difference will be there. See, I am exaggerating, but in reality, only few centimeters of difference is there. So what happens? See, water will be following that water type of balancing. So what happens is surplus water, my dear friends, it will start moving towards the Peruvian coast. So the warm waters from the Peruvian coast will start moving towards the Australian coast. At one point of time, finally, this warm water will be reaching the Peruvian coast. That is what you can see here. This image, you can see here that warm water from Australian coast is moving towards the Peruvian coast. Once this warm water reaches the Peruvian coast already I have a cold current there. So cold current will be denser. So the warm water will be superimposing this cold current. Okay. So what happens, my dear friends, in the surface of the water or surface water, I will not have cold current anymore. This cold current will be replaced by this warm water. So when this Peru current or the cold Peru current, if it is being replaced by the warm water, that condition we call them as what? El Nino. So if you want to understand in simplicity, what is El Nino? Simple. Normal condition, American coastline or Peruvian coastline. Normally, it is cold condition because it comes under the influence of Peru current. Sometimes it is also called as Humboldt current. In your atlas, you will be given as Humboldt current. It will be given as Humboldt current. Okay. This Humboldt current is being replaced by warm water. The condition you call them as what? So once the cold water gets replaced by warm water, what happens? The Peruvian coast will become a low pressure and Australian coast will relatively become a high pressure. So what happens? This wind will go for a reversal. Normally, what happens in this region, I'll be having a trade wind which will be flowing. We call them as what? Southeastern trade of southern hemisphere. But here it goes for a reversal. Either the southeastern trade wind of Pacific Ocean will become weak or it will be going for a reversal. So, when the southeastern trade of Pacific Ocean becomes weak, my dear friends, it is becoming weak, then what happens? All the wind that is supposed to come to India will not come. Only half the wind will be coming. If that is the case, Indian monsoon will get what? Affected. That's why we normally say El Nino is a bad news for India. But see, we do have a compensating mechanism. We do have it. But normally we say it is not a good news as such. Okay. So in between I had one warm water breeze follows. Uh, swing the okay warm water breeze flows towards America, Peru, etc. Yeah, yeah. Right, right, my dear friends. Now, what is El Nino? Again, in one word, if you want me to tell me, or one sentence, if you want me to tell you, simple. Peruvian current being replaced by warm water. That's it. But where exactly this warm water comes from? Australian coast. Okay, right. So El Nino is not a good news for India. But see, we say El Nino will be affecting Indian monsoon, but during El Nino, Peruvian coast becomes low pressure. If it is becoming low pressure, my dear friends, Peruvian coast will become wet. And one more thing, see, there are some basic logic. What is the basic logic? Wherever I have a low pressure, take it for granted you will be having a wet condition. Wherever I have a high pressure, take it for granted I will be having what? Sorry, dry conditions. Dry conditions. See, barring few exceptions, this is universal. This is universal. These are basic concepts. Okay. So that's the reason normally we say wherever I have the influence of a cold current, I'll be having cold current. Cold current will be inducing what? High pressure. And this high pressure will induce what? Dry condition. That's the reason, my difference. Wherever I have a cold current, the adjoining coast will be dry. Any desert, normally you take it. Alongside desert, what you will be having is a cold, say for example, current that is flowing. Okay. So El Nino this year, my dear friends, I feel it is important. Who knows? UPSC and all, we just can anticipate. We cannot actually predict it. Okay. Then what is La Nina? La Nina is a normal condition. This water will be going for an oscillation, right? To and fro movement of the water will be there. It will be going for an oscillation. Okay. Right. That story is not needed. But still, if you want to, right, know the story, how exactly this water again goes back. Very simple. Right. I know what is El Nino now. Right? Australian coast, the warm water started moving towards the Peruvian coast. Now the Peruvian current is being replaced by warm water. I know it. Now there is no difference. Okay. Now what happens? Peruvian coast becomes a low pressure. Peruvian coast become very, very wet. And slightly this surplus, say for example, precipitation surplus will be created. And once the precipitation surplus of water is created, again the water will start moving towards what? Australian coast. So once the water starts moving towards the Australian coast, my dear friends, what happens? That current or that water which once went subsurface again comes to the surface. When the cold Peruvian current gets re-established back into the surface, this condition either you call them as what? La Nina or normal years. See, La Nina and normal years, there is a small difference. There is a small difference. Okay. It means La Nina is a condition which immediately follows what? The, say for example, it immediately follows the El Nino conditions, right? If a normalcy returns after a El Nino, that condition we call them as what? La Nina. Okay. So otherwise, I can, without getting into the details, if you ask me, La Nina can be regarded more like a normal year, right? Say for example, northeast monsoon is a normal condition, but once the normalcy returns after the reversal condition, you have a specific name for it. Okay, right. Right, my friends. Now, what is El Nino? What is La Nina? We have an idea. For a successful southwest monsoon, what exactly is the condition needed? That also we have taken it. And somewhere I have just given you a graphical representation where El Nino and La Nina condition I am just telling you. Right. During El Nino, what happens? Australia comes under the influence of a cold current or cold waters. Right. So when I say cold waters, it induces dry condition. South America, Peru and Chile comes under the influence of warm currents or warm waters. So it becomes what? That's what I'm just graphically trying to represent. Okay. Right, my dear friends. Now, see, we have one counter mechanism or counterbalancing mechanism. My dear friends. What is this counter mechanism or counterbalancing mechanism? Okay. What is this counterbalance mechanism? Somewhere I said, my dear friends, for having a successful Indian monsoon, southeastern trade. Okay, instead of using this word called as strong, I'll use this word called as moderate, even if it is moderate. Right? Southeastern trade of Indian Ocean if it is moderate, and southeastern trade of Pacific Ocean if it is moderate. The southwest monsoon will be a success. Right? It will be a success. Okay. Now, during El Nino condition, what happens, my dear friends? During El Nino, if I'm just talking about El Nino condition, the southeastern trade of Pacific Ocean either becomes weak or goes for a reverse. Right? It becomes weak. So, to compensate the effect of El Nino, if I have a strong southeastern trade of Indian Ocean, then also the southwest monsoon can be successful. It means if I have some phenomena or mechanism which ensures a very strong southeastern trade of Indian Ocean, right? Even if I have El Nino, that is not going to affect our monsoon. That's what the logic is. Then if you ask me, what is the counterbalancing mechanism we have in Indian Ocean, if you ask me, you call them as what? Indian Ocean dipole. The similar phenomenon. What we normally, right, happens in Pacific Ocean, the similar phenomena also happens in Indian Ocean. You call them as what? Positive phase and negative phase. This is a temperature anomaly. Temperature anomaly recorded along the same latitudinal waters, you call them as what? Dipole. For example, Indian Ocean dipole, we have both positive and negative phase, right? Positive phase is also there, negative phase is also there. When I talk about this positive phase, my dear friends, what is positive phase? It is more like a normal condition, right? The western side of the ocean, warm waters, the eastern side of the ocean, cold water. So what happens? A low pressure will be created somewhere in the African coastline. High pressure will be created somewhere over Australian coastline. So what happens? I'll be having a very strong southeastern trade, right? Irrespective, even if I have El Nino, if I have a strong Indian Ocean dipole positive phase, it will be ensuring that the southeastern trade of Indian Ocean becomes very strong. If that is the case, monsoons, Indian monsoon will also be what? Successful. Okay? Right, my dear friends. And the reversal condition, we call them as IOD negative phase. IOD negative phase is also negative for India. Negative in the sense, it makes the southeastern trade weak. Right? Right, my dear friends. Now, similar condition. What is, say, for example, what is La Nina in Pacific Ocean is Indian Ocean dipole positive phase in Indian Ocean. What is El Nino in Pacific Ocean is very similar to IOD negative phase in Indian Ocean. You're getting it? Normal condition, western side of the ocean is warm. Right? Reverse the condition, you take it. IOD negative phase is the reversed condition. El Nino is the reversed condition. IOD positive phase is the normal condition. La Nina is a normal condition. Okay. So, my dear friends, for Indian monsoon, successful Indian monsoon, this normal condition is much needed. Okay. So, what is El Nino? What is La Nina? We have an idea. Okay. Now, I'm just going for a combination, my dear friends. What is this combination? This combination is completely theoretical. Why I say theoretical? See, for example, when I say theoretical, not necessarily that you will be experiencing this in reality, not necessarily. Okay, I'm just giving you all these combinations. For example, what is the point? What I'm just trying to say, even if I have El Nino in Pacific Ocean, but if I have a compensating factor in Indian Ocean, my monsoon will be moderate. Having a moderate monsoon itself is success. Okay, right? That's what the point, what I'm just trying to say. And all combinations I have just taken it. See, if I have both, La Nina is also favorable for Indian monsoon. IOD positive phase is also favorable. During that time, what happens? You'll be having surplus. Surplus in the sense what? We'll be having what? A flood-like situation. Okay. I have just given you somewhere the combinational chart, completely theoretical, right? But what we understand, Indian Ocean dipole positive phase has all ability to counterbalance the effect of El Nino. And it has happened in the past also. Right? If it can happen in the past, certainly speaking, in the future also, El Nino, if it is somewhere overlapping with Indian Ocean positive phase, IOD, Indian Ocean dipole positive phase, that too during the period of monsoon. See, for example, if I am having El Nino in the month of June, July, and August, along with September, that El Nino can affect Indian monsoon. El Nino, if I am experiencing in the month of December, January, February, by the month of March, the El Nino is over, that is not going to affect Indian monsoon. Okay? Right, my dear friends. Right. So, what is El Nino? What is La Nina? We have an idea. See, and one more thing. Normally, on an average, El Nino occurs once in 6 to 7 years. By, but very recently, we are finding that this average number of years has trickled down to somewhere around 2.5 to 3 years. See, now we are having after 5 years. We do not have a specific number of years after which this El Nino will occur. 2018 we had El Nino. After 2018 it is 2023, right? We had 5 years of gap. Okay, but on an average it is 2.5 or 2.5 years to 3 years once we are somewhere having this El Nino occurrence. What can be the reason? If no reasons in climatology can be somewhere taken, right, or somewhere it is brought. always you have a reason, right? And you can say that it is all because of, right? Now, whenever I just talk about these unexplained things, always I can say it is all because of climate change, global warming, etc. Okay. So that's all about monsoon, my difference. I strongly feel that monsoon is a very important topic for this year, given the El Nino. Okay. And some of the question which is asked in the past, the seasonal reversal of wind is typical character of which climate? We know it is monsoon, right? With reference to IOD, sometimes mentioned in the news while forecasting Indian monsoon, which of the following statement is right? Okay, just go through it. They say IOD positive, IOD phenomena is characterized by a difference in sea temperature between tropical Western Indian Ocean and tropical Eastern Pacific Ocean. My dear friends, name itself is Indian Ocean dipole, right? Name itself says it is Indian Ocean. Why do you want to take Pacific Ocean? Okay, it is only Indian Ocean. Answer is statement one is wrong. And IOD phenomena can influence El Nino's impact on the monsoon. That's what we were explaining. Right? Answer to the question is what? Two only. Right? Right, my friends. Now, one more question was asked. La Nina is suspected to have caused recent flood in Australia. Right? How El Nino is different from La Nina. That's what they're saying. Right? You read it and try to answer by yourself. Right? Fine, my friends. One more question was asked in the past. The duration of monsoon decreases from southern India to northern India. This will try to cover it in Indian geography that we'll be doing in tomorrow's class. Right? Okay, again, one more question is associated with what? Monsoon as a mechanism. Okay. So monsoon is a very important topic for your preliminary examination. So one more topic also we have, which is equally important for your preliminary examination. It is the World Climatic Classification. The World Climatic Classification. Let's see. When I talk about this World Climatic Classification, my friends. Okay. Okay. Slightly it is visible. Okay. Right. See, this classification, what I'm just bringing in, my difference. This is more like a combined work of G.C. Leong and Copen. The concept I have just taken from Copen's classification, but the names, most of the time, the names I have just taken from G.C. Leong's classification because Copen has given more of alphabets. You don't call it as equatorial type of climate. Instead of equatorial type of climate, you call them as AF type of a climate. Monsoonal type of climate, he call it as AM type of a climate. Desert, he call it as BW, say for example, H type of a climate, right? Desert. Mediterranean, he called them as what? CES type of a climate. Okay. China type of a climate, he called them as what? CW type of a climate. This cold desert, he called them as what? BWK type of a climate, right? Steppe, you call them as what? BS type of a climate. So what I just want to tell you, British type of climate, he calls it as CF type of a climate. Okay, whatever it is the case, right? He has given more of alphabets. Even NCRT is carrying that alphabets. That is not needed. That is not needed. Only thing is that again and again I'm insisting that the name of this paper is General Studies. Okay, so that word General Studies has to be there. Okay, that we have to somewhere justify it. Okay, that is very, very important. Okay, so having said this, my dear friends, having said this, right, now, okay, world climate as such, right, we have just taken it. So somewhere, as I said, world climate, when I talk about world climate, my dear friends, this classification, I have just classified based on temperature and moisture. For temperature, only one factor I have taken it, latitude. It's a very narrow way of classifying. I have not done it. Scholars have done it, I am only replicating it, right? For temperature, only latitude is taken. For all practical purpose, altitude and other factors are not taken, right? And for, say, for example, moisture, what determines the moisture? Moisture is carried by wind. And when I talk about wind, I have only two types of wind. Either it will be an easterly wind or it will be a westerly wind. Okay. A wind which comes from the eastern direction or easterly, sorry, eastern direction, you call them as easterly. Wind which comes from west, you call them as what? Westerly. Right. In that way, the west coast of a continent will be coming under the influence of a westerly wind. The east coast of a continent will be coming under the influence of a easterly wind. That's the reason. Some of the continents I am just also dividing as west margins of the continent, east margins of the continent, and continental interiors. Why? To justify the impact of this easterly and westerly winds. Okay. So, right, my difference totally the regional climate, what we can somewhere take it, largely 13 different types of climates are there. But for examination, I would say it is 4 plus 4. Four climates are very, very important. What are the climates which is very, very important? Equatorial type of climate 1, savanna 2, tropical deserts 3, and Mediterranean 4. Monsoonal type of climate, already you know it. That's the reason I'm not insisting. Apart from that, another 4 if you want to add it, my dear friends. Cold desert, some of the basic facts. Steppe, some of the basic facts. British type of climates are the basic fact. Taiga, some of the basic facts. Tundra, you already know it. Am I right? China type of climate will not take it. Even if it is important, I am not interested. Okay, something like that. Okay. Now, somewhere, my dear friends, we'll talk about somewhere around 4 plus 4. I think that is ideal, right? 4 plus 4. These are often asked questions in the examination as such. Okay. Now, having said this, one by one, I'll just take it and see some of the correlation is also is there. That correlation is also very important. Okay. How come we have arrived at this climate is very simple, my dear friends. See here. For giving the names and all, first we have developed a grid first, like this, right? Like this, I have just developed a grid, right? So what is the, say for example, significance of this grid? Latitudinally, we have divided, and east and west margin of the continents also I have just divided, right? So post division, somewhere in this grid I am overlapping with the combined landmass of Europe, Asia, and Africa. Just for giving a name. Climate as a concept is applicable only to the land. Influence of the ocean can be felt in what? Land. Okay. Influence of ocean can be felt in land. But oceans do not have a climate as such. Per se, ocean do not have a climate. Okay. But oceanic influence is already there. Exactly, I'm just overlapping it. But of course, with all practicality, I'm just applying it. Of course, this climatic grid may not work in high altitudinal mountains. It may not work in, say, for example, considerably heighted plateaus. Okay. The low heighted plateaus, less altitudinal plateaus, along with the plains of the world, this grid will beautifully work. Okay. So wherever I superimpose it, for example, we have a specific type of a climate. For example, right, the 0 to 10 degree, only in northern hemisphere. Just for giving a name, I'm just giving it. Okay, northern hemisphere, right? Say for example, the eastern side of tropical region, tropical east margin, we have India. India experienced monsoonal type of climate. So we have given a name called as monsoon. Correct. The western side, what we find is world's largest desert, Sahara, and extension of Sahara into Asia, we have in the name of what? Arabian desert or Rubal Khali. Right. That's the reason. The entire region we call them as what? Desert. Of course, subtropical east margin, we have this country called as China. We call this as China type of a climate. Continental interior, some of the cold deserts of the world is located here. For example, the most famous desert, popular deserts like Gobi Desert, Taklamakan, Gurbantu Nagat, Shamavu, plenty of deserts over there. When I talk about the western side, of course, I have the Mediterranean basin, and accordingly, we call this as Mediterranean type of climate. Okay. Then, say for example, we have the Chinese plains in the eastern side, the plain of China, you call them as what? Manchurian plains, and this type of climate is also called as Manchurian type of climate, or you call them as what? Laurentian type of a climate. Okay. Temperate west margin, we have the larger part of Europe, or say for example, this is a place where I have this British island. That's the reason. This temperate west margin, either you call them as British type of climate or European type of climate. In between, you have one of the considerable, the largest steppe of the world, or one of the largest steppe of the world called as what? Kyrgyz steppe. That's the reason this region you call them as what? Steppe. Okay. And beyond it, what you have is taiga. You have taiga, you have tundra, and you have the frosted region. Don't even call it as polar region. Let me call it as what? Frosted region. Because, see, we are habituated, whenever I say, even I think the last image also I've used this word called as polar. Okay. But for all practical reasons, somewhere I can take it. This polar here contextually means I'm talking about what? The frosted regions. Okay. Completely frozen region. Because technically speaking, till 66.5 degree, till your Arctic Circle, my dear friends, till your Arctic Circle, you call them as what? Polar region. So better we'll call it as what? Frosted regions as such. Okay. Right. So this is all about this classification. Now what we have to do? 4 plus 4. I said 4 plus 4. Right? At 4 plus 4, I'll take it. So the very important facts alone, we'll just take it. Very important facts. In that way, my dear friends. Equatorial type of climate, unique features, equatorial type of climate, my dear friends. Normally, where exactly this equatorial type of climate extends 10 degree north, 10 degree south? right? Normally. See, some of the books you will be finding 5 degree north to 5 degrees south. Doesn't matter. Doesn't matter. Okay. I understand that the equatorial region will be experiencing high position, sun's position throughout the year. Throughout the year, I'll be having high sun position. If that is the case, throughout the year, I'll be having what? High temperature. That's the reason normally we say equatorial region will be hot. Okay. And my difference, because of high temperature, what happens? The air mass will be rising. It will be going for a convective rise. And as and when the air mass rises, it will be going for condensation. It will be resulting in precipitation. Am I right? That precipitation, we call them as what? Convectional precipitation. Almost every day. I'm not saying every day. I'm using this word called as what? Almost. Almost every day. Right? It precipitates. Okay. And when I talk about the amount of precipitation received, it is more than 300 centimeter. Right? Because of this fact, my dear friends, it becomes par moist. Par moist means very wet. And let me tell you, my dear friends, as a climatic region, this is regarded as the wettest climate. Small clarification, I am not saying that this is the wettest location. No. Which is the wettest location? That wettest location happens to be in India itself. Correct? Mawsynram is regarded as the wettest location of the world, not even Cherrapunji, because according to the data, what is with IMD, Indian Meteorological Department, it is more like what? Mawsynram. The data which is available with the WMO, World Meteorological Organization, it is Cherrapunji. But I should understand Cherrapunji and Mawsynram itself is not a two. Say, for example, different places separated by a very long distance. The aerial difference is less than 20 kilometers. Right? Cherrapunji and Mawsynram. Meghalaya, name itself says Meghalaya. Am I right? So I'm not saying the wettest location, my dear friends. What I'm claiming that this is the wettest climate in the world. Right? Somewhere 300 centimeters of precipitation. Right? 300 centimeters. Almost every day it precipitates. Okay. So as a result, my dear friends, what you have is an evergreen forest, equatorial rainforest. Okay. Now here, the most important fact here, most important fact. I would say this is unique. If examiner talks about this particular statement, you're identified, okay, he's talking about equatorial type of climate. It means what? He says almost every day is similar. There is no difference between different days of a year. It means no season cycle. It means no season cycle. There's the only place on earth where I do not have season. There is no concept of summer. There is no concept of winter. There is no concept of spring and autumn. Every day it is more or less same. Because right at the equator, I understand, it experience equinox every day. Right? And that's the reason, my dear friends, equatorial region is the one which experiences the minimum annual range of temperature. Minimum. What is annual range of temperature? The difference between maximum and minimum temperature of a year, you call them as what? Range, annual range. Minimum is generally recorded during winter, maximum is generally recorded during summer. But here, I don't have winter, I don't have summer. See, winter means low temperature, summer means high temperature. That's okay. But here, I don't have summer, I don't have winter. That's the reason annual range of temperature. Entire earth you take it. Where exactly I'll be having the minimum annual range of temperature in equatorial region. Okay. So see the unique facts. Rainfall happens almost every day. Only 3 regions of the world where rainfall happens almost every day or throughout the year. Equatorial region is 1, British type of climate is 2, and taiga type of climate is 3. Right? All other regions you take it, somewhere I'll be having concentrated precipitation. Only during certain period of the year I'll be having this precipitation that is taking place. Right? Right, my friends. And most important fact, as I would say, is the only climate in the world which do not experience season cycle. There is no season cycle. Right? There is no season cycle as such. Okay. Right, my friends. So equatorial type of climate, some basic facts we have just given. And some of the regions in the world which experience equatorial type of climate, that also I have just given it. Okay. Right, my friends. Now the second climate, equally important. Tropical desert. Tropical deserts, my friends. See, only thing is that I should understand 3 aspects of a desert. What is a desert? Where all we have a desert? And why this place has become a desert? It means I have to answer these 3 W's. Am I right? I have to answer these WH questions. What is a desert? Where is a desert? And why this place has become a desert? First and foremost, what is a desert? Normally we say any place which receives less than 30 centimeters of annual precipitation and which is not dependable. See, that doesn't mean that if a region experiences less than 30 centimeters, not necessarily it will be a desert. That's the reason maybe slightly I'm adding one more term called as not dependable. It means this precipitated water may not be useful for natural or man-made vegetations, right? That's what we say, that any place which receives less than 30 centimeters of annual precipitation, which is not dependable. Even dependable word also you leave it, right? Why to complicate it? Okay. Very less amount of water. You call them as what? Desert. Desert is the place where evaporation will be more dominant than precipitation. Wherever evaporation is more dominant than precipitation, that region will be dry, irrespective of the amount of precipitation you experience. Assume that, okay, 100 centimeter also experience. Assume that I am experiencing 100 centimeter of precipitation, but all that precipitated water within a day or two, if it is getting re-evaporated, somewhere I understand evaporation is more dominant. So wherever evaporation is more dominant than the precipitation, they're all, you may experience what? Dry condition. That's the idea. Right? Right, my dear friends. Now, what is a desert we have taken? Now, where all we have a desert? See, tropical region, 10-degree north to 30-degree north. You're there in the western side of the continent. You're there in North America, Sonoran Desert. USA, you have this desert called as Mojave Desert. You call them as what? Mojave Desert. South America, 10 degrees south to 30 degrees south. We have this one of the driest desert of the world called as what? Atacama Desert. Okay. Africa, northern part of Africa, we have the Sahara. Continuation of Sahara in, say, for example, right? Arabian Peninsula, Saudi Arabia. Am I right? Visit Saudi, go beyond the boundaries. That's what they are saying nowadays. Okay, whatever it is the case, right? You're there in Saudi Arabia, you have this desert called as Rub al Khali. Right? Again, say for example, the western part of the desert or western part of the continent, the southern part of Africa, you have this Namib Desert, Kalahari Desert, right? Namibia, you have this Namib Desert. Botswana, you have this Kalahari Desert, correct? And the western side of Australia, you have what? Australian Desert, the Great Sandy Desert, the Great Gibson Desert, the Great Victorian Desert. So many deserts are there. My dear friends, one thing is very common. Where you find desert? Tropical region, 10 degree to 30 degree, both the hemispheres. Both the hemisphere have a desert. Which side of the continent? Western side of the continent. Okay. So what we have answered? Where we have answered. That's the reason I said tropical west margin of the continent. Now you may wonder, what is this? Some of the places this desert is, say for example, very small. Some of the places this desert is very large. Simple. I have to see the land what I have selected. See the continuation of the land. This land itself is so big that the western side of the continent eventually also becomes what? Very, very large. Here the land selected is what? Very less. That's the reason western side becomes what? Very small. Apart from that, of course, we have one of the mightiest mountains of the world here in the name of what? Rocky Mountains. Okay. But see, the same Africa, northern part of Africa, see the beauty. How large a desert is. Right? But when I talk about the southern part of Africa, that's not so extensive because the selected land itself is what? Small. So the western side of the continent itself becomes what? Very less. Okay. Right, my friends. Now, what is a desert? Where all we have a desert, we have an idea. Now comes the question. Why this place is a desert? Why? Why desert is a desert? My friends, three reasons are cited. Number one, this region, see, this is a tropical region. Tropical region comes under the influence of trade wind. If you're there in northern hemisphere, it is northeastern trade wind. That's what I have taken. Right? Assume that you are there in northern hemisphere. This region comes under the influence of northeastern trade. And trade wind is an easterly wind. When I say easterly wind, my dear friends, I know the fact that easterly winds flows from what? East to west. So given the flow direction, my dear friends, throughout the year, I understand that this wind is flowing towards what? Or it is flowing from land to sea. It is moving from land to sea or ocean. Am I right? It means throughout the year, perennial, throughout the year, this region comes under the influence of offshore trade wind. Even trade wind, you forget about it. Throughout the year, it comes under the influence of offshore winds. And my dear friends, two types of wind. I'll be having onshore wind. Onshore wind means a wind which is coming from water to land. Southwest monsoon is more like an onshore wind. Northeastern monsoon to major part of India, it is more like offshore winds. Any onshore wind will be wet. Any offshore wind will be dry. Because this wind is moving from land to sea. There is no avenues of moisture in what land, very minimal. Am I right? But when a wind comes from ocean to land, that wind will be collecting the moisture, carrying the moisture, delivering the moisture in the land. Okay. My dear friends, this region comes under the influence of what? Offshore trade wind. This is the primary reason why exactly this region has become what? Desert. Then every desert what we have taken, very carefully if I look at the earlier diagram what we have taken, my dear friends, see here. The earlier diagram what we have taken, every desert, adjoining every desert, the major desert what we have taken, right? Alongside this desert, what you happen to find is a cold current. Sonoran Desert, Californian current. Atacama Desert, Peruvian current. Saharan Desert, Canary current. Namib Desert, Benguela current. The Australian deserts, West Australian current. All these are cold currents. And I was already told you, cold current generally results in creation of a high pressure. High pressure results in inducing that dry condition. Even say, for example, winters also you take it. Winters will be what? Dry. Summers will be wet. Okay. See, hot and humid, you say. Humidity is all about moisture. See, we are not enjoying it. That's a different story. But somewhere I can understand winter. When exactly use your moisturizers? During your winters. Because winter air mass carries very less amount of moisture. Okay. So why exactly winters are dry? Because winters are known for high pressure. Why winters are known for high pressure? Because it induces cold conditions. That's it. Right? So whichever region comes under the influence of cold current, those regions, I understand, maybe there is a chance that, right, they'll also become what? Dry as such. Okay. So two reasons we have cited. And what is the third reason, my dear friends? This region is more a region of a high pressure. Interesting, right? Tropical desert, how come high pressure? Tropical deserts are the one which records one of the highest temperature. For example, even in India, when I talk about, say, for example, the hottest place, if not hottest city in India. Why hottest place? Hottest city in India. There is a city called as Jaisalmer. Jaisalmer is regarded as the hottest city in India. Because Jaisalmer is located in the middle of this Thar desert. Correct? If that is the case, my dear friends, why Jaisalmer is hot? Because it is a desert. Surrounded by desert. Desert is very hot. But what is very interesting? The high temperature in desert is short-lived. What is more permanent is interestingly cold condition because the desert which is warm during the daytime will be extremely cold during the night time. Technically, we say the diurnal variation, my dear friends. Diurnal. Diurnal variation or diurnal temperature means the range of temperature in a single day, we call them as what? Diurnal. So, where exactly this diurnal temperature will be maximum, if you ask me? Diurnal temperature will be maximum in what deserts? The two sandy desert, right? So, day temperature will be very high, whereas night temperature will be extremely cold, right? Sometimes there are instances where it goes sub-zero condition also, if not in India, other continental deserts of the world, extremely cold. Okay. So, on an average, if you ask me, which condition prevailing in desert is more dominant? Interestingly, it is not high temperature. It is cold conditions. Okay. See, the high temperature in desert, my dear friends, when I talk about high temperature in desert, somewhere I'll take it even morning 8 a.m. to 4 p.m. Only for example, 8 hours, the temperature is generally higher. But when I talk about low temperature, remaining 16 hours, it is low temperature. It means what is more common here is not the low pressure, it is high pressure. And high pressure, I know. Again, high pressure induces what? Dry condition. See, my difference. See, any offshore wind induces dry condition. Cold current induces dry condition. High pressure induces dry condition. It means all the condition that is prevailing in desert is somewhere making desert what? Dry. Very important understanding. Okay? Right. So that's all about desert, tropical desert. Equatorial type of climate is also very important. Tropical desert is also very important. Now coming to the third type of climate, savanna. Sometimes G.C. Leong used to call this type of climate as what? Sudan type of a climate. Sudan type. Because Sudan is there in news. Who knows? Sudan type of climate can also be asked. See, today we don't have savanna in Sudan. We don't have savanna in Sudan. Only South Sudan has. Only South Sudan has. And GC Leong has classified there was no South Sudan. South Sudan was one of the youngest countries of what? Africa as such. So the savanna is a tropical grassland, my dear friends, and known for a very tall grasses, very tall grasses. Imagine, sometimes if you're not able to recollect the fact, at least the picture you can recollect it. It's semi-arid region. Why it is semi-arid, if you ask me? Because it is far away from both the coastline. Continentality is the reason for this semi-arid nature. And let me tell you, my dear friends, we normally call this type of climate as a true transitional type of a climate. Why true transitional type of a climate? I'll tell you. Because, see, savanna, same latitude, one side desert, dry, extremely dry. Another side monsoon, extremely wet. Same longitude, the higher latitude, again cold desert, extremely dry. Equatorial region, extremely wet. So take it along the same latitude or take it along the same longitude. Savanna separates two extreme forms of climate. That's the reason savanna, you call them as what? A continental or a true transitional type of a climate. Okay. So why savanna is dry? Neither the westerly wind nor the easterly wind will bring the moisture. By the time they reach this place, hardly very little amount of moisture will be left. I'm not saying that it will not experience precipitation. The amount of moisture left will be what? Very, very less. Okay. And even, okay, Tunisia is more like a Mediterranean type of climate. We'll talk about it, right? Now, Tunisia was there in news. Right? Tunisia for the water crisis, Tunisia was there. Libya was known for the water crisis. Because, say, for example, we'll come to this Mediterranean region, we'll discuss about it. Okay, right. Right, my dear friends. Now, some basic facts about this tropical savanna I have just given you. And see, savanna, something, say, for example, it is a home for large terrestrial animals, right? You imagine savanna, what will strike you? Is all these large terrestrial animals. Even say, for example, this Kuno National Park, where these cheetahs have been reintroduced. Till today, if my statistics are correct, it means at least three of them we have lost. Okay. But they say even 50% if they survive, they say that it's a great success or survival rate, they say. Okay. Whatever it is the case, right? Now, somewhere they normally get adopted to savanna type of vegetation. Okay, grasslands. So, grasslands or the savannas is generally the house for large terrestrial animals. Okay, right, my dear friends. Now, having said this, some of the savannas of the world takes a specific name. For example, Llanos. If you're there in Venezuela, right, you have this savanna called as Llanos. Then, if you're there in Brazil, my dear friends, you have this savanna called as Campos. Savanna called as Campos. African savanna happens to be the world's largest savanna, where exactly even South Sudan is included here. South Sudan. Okay. And even Australia, Carpathian Plains and Nullarbor Plains also happens to be that savanna of the, some very important savannas of the world. See, India largely savanna is missing, but still here and there sporadic savannas are there. Okay, right. Then three climates we have done with. The important climates we have done with. Coming to the fourth very important type of climate, Mediterranean climate. See, Mediterranean Sea is very important. Mediterranean climate is also very, very important. Okay. In that way, my dear friends, we talk about Mediterranean climate. You're there in the subtropical region. Subtropical region. You're there in the western side of the continent. See here, somewhere if I just take it. You're there in the subtropical region, 30 degree to 45 degree. You're there in the western side of the continent. What I find is Mediterranean Sea. The countries around this, we call them as what? Mediterranean basins. We call them as what? Mediterranean basins. Okay. Right, my dear friends. Now, a Mediterranean type of climate is very important for n number of reasons of it. Right. What are the reasons? Number one. Normally, when I talk about equatorial region, British type of climate, taiga, etc., I know one fact that these regions are known for precipitation happening throughout the year. Otherwise, barring this exception, rest of the climate, if I take it, precipitations, they are almost confined or concentrated during the specific season, my dear friends. When exactly precipitation are generally concentrated? Summers. Normal. India as a classical example. When talk about southwest monsoon, it is June, July. When talk about June and July, June is summer solstice, peak days of a summer. July is also summer, right? So which month is wet if you ask me in Indian context? It is summer. All right. Because it is becoming wet, we are not feeling the temperature, but longer days you'll experience that. June 21st will be the longest day, but you will be experiencing what? Right, southwest monsoon also. India, southwest monsoon will start on 1st of June, right? Onset of monsoon, Malabar coast, Kerala coast, it will start. Now, normally I say for example, summers will be wet and winters will be dry. Indian again, same example I can take it. When I talk about Indian, say for example, the seasons, I have 4 seasons. Global classification is different, but Indian classification is different. Dry winters, dry summers, advancing monsoon and retreating monsoon. We talk about dry winter, see, winter is dry. Okay. In that way, my dear friends, when I talk about any region you normally take it, summers will be wet and winters will be dry. But Mediterranean is exactly opposite. Winters are known for concentrated precipitation. It means it is known for wet winters. When water is not needed, water is there everywhere. All right. When water is needed, water you don't get it. For example, summers are known for long and drought-prone summers. Tunisia, the classical case, you can take Tunisia nowadays, right? Tunisia is experiencing an extraordinary, say, for example, drought-like condition. Not only that, even Spain for that case, right? Summers will be very, very very tough, because summers are known for drought-prone regions or drought-prone seasons, sorry, seasons as such. Okay, winters wet, summers dry, right? Summers dry. This is the most important property of this Mediterranean type of climate. Okay. But whatever it is the case, annual amount of precipitation, if I calculate it, somewhere it receives up to 75 centimeters of precipitation. Okay. Right, my friends. Having talking about this Mediterranean type of climate, right? Why exactly summers or dry, winters or wet, I should understand. For example, see, I know normally you have a pressure belt called as subtropical high. The subtropical high is generally located between 30 degree and 35 degree in both the hemisphere. And I also know the fact that these pressure belts will be shifting north during what? Summers. That's what you're experiencing here. During summers, what happens? During summers, subtropical high is shifting north. Because it is shifting north, what winds? Two winds that emerges from subtropical high. One is westerly, another is trade wind. If I talk about the nature of this trade wind, this nature of the trade wind is offshore trade wind. It means the wind which blows or flows over Mediterranean region during this season is offshore trade wind. And any offshore wind is a dry wind. Forget about the name of the wind. It will be a dry wind. On the other hand, my dear friends, when I talk about, say, for example, winters pressure belt will be shifting south. When it shifts south, what happens? The westerly wind will be having its influence. It will be entering this Mediterranean region. And see the nature of this wind. This wind is an onshore wind. This wind is an onshore wind. Okay. So during summers, this wind or this region comes under the influence of offshore wind, trade wind. And during winters, it comes under the influence of onshore wind, westerly. Any onshore wind will be wet. Any offshore wind will be dry. So I can understand why Mediterranean region is wet during winters and dry during summers. Okay. It's all about shifting of pressure winds, right? It is all about summers being influenced by offshore wind and winters being influenced by onshore wind. And my dear friends, different regions in the world which experience this Mediterranean type of climate, that is very important, right? That is very important. Right, my dear friends. Now, some of the regions I have also given it, but mostly you will be finding this commonality where I call it as sands and seas. California Sea, right? San Francisco, say for example, almost San Jones, San Diego, right? All these sands. Central Chile, C and C. The capital of Central Chile or Chile, right? Santiago, again San. Am I right? Cape Town, C. Okay. So that's the reason most of the Mediterranean locations will be overlapping with sands and seas by difference, right? Of course, we do have an exception, right? Exception comes in the name of what? Australia. So Australian names alone, I feel it is important. It is important. In that way, in what way Australian names are very important, I'll tell you. For example, Australia, if you're there in Australia, the western side, the Perth is a classical example of Mediterranean type of climate. And even Airy Peninsula. See, Airy Peninsula, you may object, what is this? Airy Peninsula is not located in the west, but how come Mediterranean type of climate? All these regions you take it, west margins, coastline. All right, all this western side of the continent you find. Okay. But how come Airy Peninsula is becoming west margin? Very simple. If I am selecting this peninsula alone, a small piece of land, both side if I have water, what I have marked it, right, Airy Peninsula, that comes along what? The west. Okay. It comes along the west. Right. Right, my friend. So it's all about Mediterranean type of climate. All important, four important types of climate we have taken. It rest is for arid. Cold desert. Subtropical continental interiors, we have cold desert. Some of the cold deserts of the world we have given it. And what is the reason? Not necessarily it should be a cold desert. Otherwise, you also call them as a continental desert, Gobi, Taklamakan, etc. India also we have a cold desert. India tropical desert also we have. And about tropical desert in India, at least two states we have tropical deserts. What are the two states? Tropical desert, hot desert, right? One is Rajasthan, western Rajasthan, and two is Gujarat, Run of Kutch region. See, the word run itself means what? Run itself means what? Desert. Correct? Right. That is tropical desert. And when I talk about cold desert, yes, we do have cold desert in the state of Ladakh, or sorry, excuse me, Union Territory of Ladakh. And even Himachal Pradesh, we have this cold desert called as Laul and Spiti Valley. Okay? We have this Laul and Spiti Valley. Right, my friends. Now, steppe. Steppe is a temperate grassland. Savanna is a tropical grassland. Steppe is a temperate grassland. Savanna was known for tall-heighted grasses. Steppe is known for short-heighted grasses. Am I right? Again, if you ask me why exactly this region is dry, continentality. See, comparatively dry. Semi-arid means dry only. See, I can divide the climate as arid, semi-arid, moist, par moist. Par moist, okay, somewhere I'll put so, right? Moist and par moist is wet. Arid and semi-arid means dry, right? Arid and semi-arid means dry. So par moist means very wet. I call them as what? Par moist. Wet I call them as what? Moist. Dry I call them as what? Semi-arid. Very dry I call them as what? Arid. Maybe that's, as a layman I can take it this way. Now, if you want to assign a value, less than 50 centimeters of precipitation, arid. Up to 100 centimeter of precipitation, it is semi-arid. Up to 200 centimeters of precipitation, it is moist. More than 200 centimeters, we call them as what? Par moist. This is another way, simple way of remaining. See, 50 into 2 is 100. 100 into 2 is 200. That way also you can very easily you can remember things. Okay. Right, my friends. Now, what is very important here? So, the very important steppe. Steppe, only Asia you call them as steppe. Because the different continents, it takes the different names as such. Except Asia, all other regions, the temperate grasslands takes the different names as I said. What are the names it takes? I'll tell you, my friends. Okay. Very important when it goes by name as such. For example, if you're there in North America, steppes are called as prairies, right? Call them as prairies. South America, you call them as what? Pampas. Particularly Argentina, you call them as what? Pampas. Names it takes. Asia and Europe, you call them as what? Steppe. Yes. Whereas South Africa, you call this as what? Veld. You call them as what? Veld. Australia, you call them as what? Downs. And New Zealand, we call them as what? Canterbury Plains. Even New Zealand also, we can leave it. Don't take too much of stuffs. Right? So all other regions, how exactly it is addressed, I have just shown you. Right? North America as prairies, South America as pampas. Asia, you call them as what? Steppe itself. South Africa, you call it by a name called as veld, and Australia, you call them as what? Downs. Okay. So these are the names by which you call them as. Okay. Right. This is all about steppe. Now, British type of climate. You're there in the temperate region. You are there in the western side of the continent. You have the larger part of the Europe. Of course, you have this Britain there. Call them as British type of climate. And my dear friends, what is very important here? This is a place where you experience precipitation happening throughout the year. Throughout the year. Throughout the year, only three regions I said, right? Equatorial region, British type. Throughout. See, though I have given this word called as not well distributed, but somewhere GS, that much detail, okay, will not take it. Every month, you'll be experiencing what? Wet condition. There is no dry months as such. Now comes the question, right? Why exactly this region experience precipitation throughout the year? Very simple, because this region comes under the influence of a westerly wind. Westerly wind. If you ask me, right, what exactly is the nature of this westerly wind? Throughout the year, I have this effectivity of onshore westerlies throughout the year, right? Throughout the year, this wind will be coming from what? Say, for example, this ocean to the, say, for example, this land as such. Okay. So, perennial effectivity of onshore westerly. Okay. Right, my dear friends. Now, British type of climate. Why exactly we have taken it? And of course, apart from British type of climate or Britain, where all we have this British type of climate, we have a province in Canada called as British Columbia. It's a kind of a coincidence we have. And southern Chile also experiences this type of climate. Only G.C. Leong, this image itself I have taken from G.C. Leong book. Okay. So whichever image you see orange in color, it belongs to G.C. Leong, right? Thanks to him. Right. Right, my friends. Even according to him, even New Zealand experienced what? British type of climate. Okay, right. Then comes the final of our discussion, taiga. My dear friends, taiga is a climate which is present only in northern hemisphere. Every other climate I said, very important. Only. See, one more climate is there. Apart from taiga, there is one more climate. This is Manchuria. Manchurian type of a climate. Or sometimes you call them as a Laurentian type of a climate. Manchurian or Laurentian type of a climate. This Manchurian or Laurentian type of a climate, somewhere I understand, this is also again confined only to northern hemisphere. Of course, we are not going to discuss about it, but I am giving you a fact. It's not only taiga which is confined only to northern hemisphere, even Manchuria or Laurentian type of climate is also confined to what? Northern hemisphere only. Okay. Now, why exactly taiga is not there in southern hemisphere? Very simple. 60° north and 70° north we have marked it. If I mark somewhere around 60° south and 70° south, right, 60° south and 70° south, the said location, I will not have any landmass. The said location has only what? Oceans. Okay. That's what I know. Say, for example, in ocean as such, we do not have the concept of climate. Okay. We do not have land in this region. That's the reason why exactly we do not have taiga type of climate in southern hemisphere. Only northern hemisphere, we have this type of climate. Okay. And my dear friends, what is very interesting here, this taiga type of a climate, precipitation happens throughout the year. As I already said, right, n number of times I have repeated this. Precipitation happens throughout the year, right, and it is well distributed. Precipitation happens throughout the year and it is well distributed, my dear friends. And if you ask me what type of precipitation is this, it's an example of frontal precipitation. Frontal. Okay. I think last class we talked about this frontal precipitation. When temperate cyclones, we talked about a front, right? So using this cold front or a front, this warm air mass will be rising. As and when the air mass rises, what happens? It will be going for condensation. It will be resulting in what? Precipitation as such. Okay. This precipitation, you call them as what? Frontal precipitation. And of course, see, the beauty, because precipitation happens throughout the year, what you have is an evergreen forest. Evergreen. Canopy of the forest will be there throughout the year. But very interestingly, this evergreen forest is resulted by just 30 centimeters of precipitation. See, one place 30 centimeter of precipitation is a desert. Okay. Another place, 30 centimeter of precipitation in taiga region. I understand. I am talking about something called as evergreen forest. And talk about evergreen forest, my dear friends. Normally, evergreen forest are identified in a place which is very wet, right? It is identified in a place which is very, very wet. But how come it is possible? Very simple. That's what I said. When we started itself, we said wherever evaporation is more dominant than precipitation, it will be experiencing what? Dry condition. You reverse it. Where precipitation is strong than evaporation, you will be experiencing wet condition. Taiga as an example, only 30 centimeters of precipitation, that is agreed. But evaporational loss will be very, very minimal. Okay. And one more word also I am adding it. This is the highest latitudinal forest biome we have. And this forest, very popularly, we call them as what? Boreal forest. Either you call them as what? Taiga forest, or sometimes you also call them as what? Boreal forest. Okay. So this is all about the climate, 8 different types of climate. What I said, it is very important. Okay. So tundra also I can add a tundra, some facts I can add. And tundra, even environment, it will be getting overlap. Okay. Right. See some of the questions which is asked in the past. Which of the following is the characteristics climate of tropical savanna region? If you ask me, rainfall throughout the year, no. Rainfall in winters only, no. Because rainfall happening throughout the year, I know what are the regions. Rainfall in winters only, I know. Say for example, rainfall in winters, it is of Mediterranean type of climate. An extreme short dry season, no. Extreme short dry season means rest of the season will be wet, no. A defined dry and wet season, yes, that can be taken because it is more like a continental counterpart of monsoonal type of climate. Okay, answer will be D. Climate is extreme, rainfall is scanty, and the people used to be nomadic herders, right? You have to identify that which region is this. Okay. Which could be the main reason for the formation of African and Eurasian desert belts? It is located in the subtropical high pressure cells. I told you, right? That's more a pressure means it is more the presence of high pressure. Statement one is correct. It is it is under the influence of warm ocean currents. This is wrong because generally deserts are under the influence of what? Cold ocean currents. So answer should be one only. Okay. The seasonal reversal of wind is typical to which means character of which climate? That already we have seen, right? Monsoonal type of a climate. And one more question. Each day is more or less the same. The morning is clear and the bright with the sea breeze. As the sun climbs high in the sky, heat mounts up, dark clouds forms, then the rain comes with thunder and lightning, but rain is over, right? So, which of the following reason describes the above passage? See, one thing, I'll tell you, each day is more or less the same. Here itself, you got the answer. When they say each day is more or less same, itself says the statement translates, the name says that there is no season cycle. Once they say there is no season cycle, the obvious answer is what? Equatorial type of climate. Okay. So what I'm just trying to say, my dear friends, this is one portion or this is one segment where the number of questions asked is what? Very, very high. Okay. Right. Now this is all about climate. We are completing climate. Climate is very, very important. And when it comes to ocean, my dear friends, I'll tell you only ocean currents is important. Tides also, maybe I can take it, but ocean currents are very important. Salinity, maybe we'll discuss about the salinity. Otherwise, the number of concepts to be discussed in ocean is what? Very, very less. Okay. So what are the areas, different areas we'll be having, dividing this entire oceanography as a chapter, if you ask me. Somewhere we can, okay. Oceanic feature, something like a landform feature, my dear friends, we do have what? Oceanic features. Like a landform feature, as I said, we do have oceanic features. Okay. Like the continental shelf, continental slope, abyssal plains, mid-oceanic ridges and trenches. Ocean water also has a property. The most two important property of the ocean water is what? One is salinity and two is what? Temperature. Then ocean water movement. Where exactly there is a physical movement of water. The localized movement of water, the circulatory movement of water, but very, very localized, you call them as what? Where there is actual true movement of water, we call them as ocean currents. And only in the coastal areas, in the intertidal zones, where exactly I'll be having the to and fro movement of the water, I call them as what? Tide. You call them as what? Ebb current and the, say for example, this, right? flood currents, or you call them as what, flood tide and ebb tide. Okay, whatever it is the case, right? See, whatever I have underlined it with the bold lines, it means it is important. Dotted lines to some extent I can import. Others, even if you're somewhere leaving it, it may not make a big difference. Okay, quick recap. Just of taking what quickly, what exactly is this oceanic feature? See, for example, what is the landform feature? Whatever lies in the outer surface of this earth, lithosphere, but lies above mean sea level, I call them as what? Landform feature. On the other hand, whatever lies on the outer surface of lithosphere but below mean sea level, you call them as what? Oceanic feature. The study of the same, you call them as what? Bathymetry. Study of ocean bottom topography. So what are the major features? See, somewhere I can see it here, right? Okay. Somewhere I'll just try to put myself here. Right. What you have is continental crust. Okay. You have this continental crust, continental slope, continental rise, abyssal plains, etc. All right. Somewhere you have these features as such. Okay. The name itself says they actually belong to this continental crust. Continental shelf belongs to continental crust. Continental slope belongs to continental crust. Continental rise also belongs to what? Continental crust. Okay, right. Right, my dear friends. Now, we talk about, say, for example, this bathymetry, right? As I already said, right? You may have a continental shelf, continental slope, continental rise, abyssal plains. Okay. All this word which has a prefix called as continental, they actually belong to continental crust. Abyssal plain completely belongs to what? Oceanic crust, right? And these are the features normally what we have along a passive boundary. What is a passive boundary? If I don't have a boundary, I call them as what? Passive boundary. It means if I don't have any tectonic plate boundary, I call them as what? Passive boundary. On the other hand, if I have a tectonic plate boundary, if I have a tectonic plate boundary, yes, I'll be having few more features. If it is a convergent boundary, then I'll be having a trench. If it is a divergent boundary, I'll be having mid-oceanic trench. Okay. So all the major features, if I just take it, there are 5 major features over there. Continental shelf, continental slope. A rise is more a transitional feature. Then I can talk about abyssal plains. Then somewhere I'm just giving you scope to see this. To call them as what? Mid-oceanic trench or deep sea trenches. Then we have this mid-oceanic trench. Okay. So these are some of the features what we have. Somewhere I have. Okay. Now you can see this oceanic trench also you can see. Okay, fine. Okay. Now here, my friends, what are the different features what we have? Approximately we have an idea. Only thing is that are the basic feature facts somewhere we have to talk about it. Okay, right. A convergent boundary, active boundaries, if it is a convergent boundary, I'll be having a trench. If it is a divergent boundary, I'll be having this mid-oceanic trench. Okay. Fine, my friends. So now, as I said, one by one we'll talk about it. First, I'll talk about this continental shelf. See, it's on the basic facts. Continental shelf, I know. It's known for a very shallow part of the ocean, my friends. Very shallow part of the ocean. See, this continental shelf was very much part of the land till recently. Till recently means till the end of Pleistocene epoch. Till the end of termination of Ice Age, this continental shelf was more of a land. And larger continental, we had a phase called as termination of Ice Age. Pleistocene epoch, what happened? The Ice Age almost came to an end. Large amount of continental glaciers, they melted. So what happens as a consequence? The mean sea level increased by 200 meters. And the mean sea level increased by 200 meters, my dear friends. All that low-lying coastal areas, it has submerged. That submerged part of the then land, today we call them as what? Continental shelf. So it is more like a, whatever, see plains, we have a larger plains, right? Whatever will be the character of a plain, that will be the character of this continental shelf. It is known for a very gentle rolling gradient. Means what? We don't have any steep slopes. And it extends up to the depth of 200 meters. And this 200 meters is what? The mean sea level increased. Am I right? Mean sea level also increased by what? 200 meters. Right? That is a vertical extension. If you ask me horizontal extension, from where to where it extends, right? It normally extends from what? Shelf break Or I can say it extends from coastline to shelf break. It is horizontal extension. A gentle, very gentle gradient. Something like that, say for example, slowly, steadily. See, place to place, the nature will change. But sometimes some places may difference. Remember places like Chandipur beach and all. Continental shelf is so gentle. Even say for example, some of the beaches in right Goa also you can find it. Say for example, it is known for what? Very gentle, right? Continental shelves as such. Okay. Right, my friends. Having said that, so where exactly this continental shelf extends, we have an idea. A vertical and horizontal extension. And let me tell you, my dear friends, this continental shelf is very, very rich in resources. Whatever is the type of resource, it can be biotic resources, finest example fishing. Energy resources, both conventional and non-conventional energy. Alright, conventional energy can be what? Offshore gas fields, offshore oil fields. Alright. Non-conventional energy, tidal energy, potential, OTECs. Alright, plenty of them are there. Even mineral resources, etc. Right? Whenever I talk about the resource base of the ocean, the resource base of the ocean is confined to continental shelf. And even see, you heard about something called as exclusive economic zone. All right. Every country, say for example, has a right which has a coastline can normally extend up to 200 nautical miles. It can have its exclusive economic zone that is being what extended. And let me tell you, this exclusive economic zone becomes meaningful only if you have a continental shelf. Otherwise, you will, I mean, somewhere it will not be become or it will not be meaningful as such. That's not the point. What I'm just trying to make it, right? And on an average, my difference, it covers somewhere around 8% of this oceanic area. Okay, continental shelf. Then continental slopes. What I can see here somewhere. It is the outer margin of the continental crust. Why I call it as an outer margin of the continental crust? The image itself will tell you my difference, right? Maybe, right? Say for example, this is your continental crust. This is your continental crust. This is the outer margins of the continental crust. That's what? Somewhere in the word format also I have just given it, right? In words I have just given it. It is the outer margin of continental crust. It is known for very steep slopes. And it has a ranging depth of anywhere between 200 to 400 meters of depth. And given the nature of the steepness of slope, generally it is devoid of what? Any deposits. Normally it occupies somewhere around 13% of oceanic areas. It means continental slope occupies a larger region than that of what? Continental shelf. That's the point. What I'm just trying to make it. Then come abyssal plains. Sometimes you call them as what? Deep sea plains or benthic plains, my friends. Other names. Purely it is oceanic crust. And it is the single largest feature. See, I know the fact. And talk about land versus water. Land versus water. Entire earth, if I just take it, land occupies 29% and water occupies 71%. That's the reason you call them as what? A blue planet. 71% of water. In that 71%, my dear friends, 75% is what? This abyssal plains. Right? It means 3/4 of it is what? Abyssal plains. It means majority, more than 50% of the world's surface area is made by this abyssal plains. This is the single largest feature. All the features, landform feature, oceanic feature, all feature you take it together, club it together. Abyssal plains will be furthermore larger than that. Okay, right. And the ranging depth, my difference, it may range anywhere between 4,000 to 6,000 meters below mean sea level. Right. You call them as a deep sea plains. You call them as what? Ocean bottom. As simple as this. Then comes trenches. See, already plate tectonic theory, we talked about trenches, but still, let me talk about trenches again. Wherever subduction is taking place, if I can talk about it, somewhere if I can see this subduction taking place, that's what I call them as a trench, visible zone of subduction. It is a linear depression in the ocean floor, but this linear depression has a depth of more than 6,000 meters below mean sea level. Very deep features, more than 6,000 meters. We call them as a Hadal feature. And where normally you find it, location-wise, where you find it, destructive boundaries. Any convergent boundaries in the ocean becomes an example of what? Destructive boundary. Right? It can be either ocean continent convergence, or it can be an example of ocean ocean convergence. It means any convergent boundary in the ocean. That is the meaning. It will be an example of a destructive boundary, because I know only oceanic crust will go for subduction. Only the subduction will be leading to what? Destruction. Very important concept wise, right? Then comes the last oceanic feature called as what? See, I've also given you some of the trenches, but see, don't worry about remembering the trench. Trenches are normally named after the location of the island. For example, see, we have this Peru-Chile trench. Why exactly it is called as Peru-Chile trench? Because it is running along the coast of Peru and Chile. This is the longest trench of the world. I have a trench called as Middle American Trench. In your atlas, it is given as Guatemala Trench because it is running along the coastline of what? Guatemala, middle of America. Aleutian Trench, Aleutian Islands. Kuril Trench because of Kuril Islands. Japan Trench because of the country called as Japan. Philippine Trench because of Philippines as a country. Java Trench because one of the island in, say, for example, Indonesia is called as Java. That's the reason, right? And of course, we have this Marianas Trench, very near to Philippines Trench, and Marianas Trench happens to be the deepest trench. So let me tell you one thing. Remembering the trench is very easy because trenches are named after the coastline, right? They are named after the coastline as such. Okay, right, my dear friends. Now, mid-oceanic ridge. Mid-oceanic ridge. Where exactly I'll be having this mid-oceanic ridge? Wherever there is a divergent boundary in the ocean. Divergent boundary in the ocean, I'll be having this mid-oceanic ridge. Location wise, as I said, in oceanic divergence, I'll be having this mid-oceanic ridge. As an example of a fissure type of volcanic activity. So somewhere I said, when there is a linear opening, the oceanic crust is very thin. If it linearly opens up, the magma comes to the surface, and because it is surrounded by water everywhere, even before it horizontally spreads, it will be going for solidification. Again, it breaks open. Again, the magma comes out, goes for solidification. Slowly, steadily, this feature will be growing vertically. Okay. Right, my friends. Now, this is what the mid-oceanic ridge is all about. Okay. Fine, my friends. This is all about the oceanic features. Now, coming to ocean water property. See, two properties are there, but we'll discuss only about the salinity, ocean water salinity. What is salinity? The amount of dissolved substance, the amount of dissolved substance, what we find in a sample seawater, we call them as what? Salinity. The number of salts that has been identified is nearly 47 different salts have been identified in ocean water. Among them, the most commonest salt is what? Sodium chloride. Maybe that is the reason why we are calling it as what? Common salt. Okay. And what is the source? How exactly the salt was added to the ocean? Very important gradation cycle. All the agents of gradation predominantly by rivers. Rivers are the major source of ocean water salinity. Now, when I say river are the major source of ocean water salinity, immediately what you will ask, how come rivers? River is a fresh water, right? Right? River is a fresh water, right? How come this river is, say, for example, almost adding this salinity to the ocean? See, first thing I should understand, river is a fresh water, that is okay. Does the word freshwater means that salinity is not there? If you ask me, no. My dear friends, maybe the very next slide, I'll be talking about this classification. What is a freshwater? Any water which has less than 0.5 percentage of salt content, right? Less than 0.5 percentage of salt content, we call them as what? Freshwater. Any water which has more than 3 percentage of salt content, we call them as what? Saline water. Anything which lies in between, we call them as what? Brackish water. Neither saline nor fresh. We call them as brackish water. Okay. Now see, salinity is not expressed in percentage. It is expressed in parts per thousand. What is percent? Name itself says percent. Percent. Cent means century. For 100 parts, how many parts are there? But when I talk about, say, for example, this right salinity is expressed in parts per thousand. For 1,000 parts, how many parts are there? If I calculate the same for 100 parts, I call them as percentage. Only thing is one more zero I have to add it. So it is 0.5 becomes 5 parts per thousand. If I have 5 parts per thousand, if the salinity is less than 5 parts per thousand, I call them as what? Fresh water. It means if I am taking 1 liter of water, in 1 liter of water, if I have less than 5 grams of salt, then I call them as fresh water. Then you may ask me again, what is this? One place you are taking volume and another place you are taking mass. Can the volume and mass be, say for example, equated, compared? Can the weight and, say for example, weight and the volume you're taking, can it be compared if you ask me? Water you can compare it because 1 kg of water, my dear friends, will be equal to 1 liter. Okay, but this does not happen at every time. Normally, this will be happening at 4 degrees centigrade where the water will be having the maximum density. Maximum density of the water is attained at 4 degrees. Interestingly, the ice cubes or the glaciers, you call it, right? Glaciers will be having less density than that of water. That's the reason glaciers are floating. It's very, say for example, every other, say for example, right? The material you take it, solid will be occupying, solid will be denser than what liquid, but water is an exception. Okay, whatever it is the case, water I said that mass and volume you can compare it. So what is my understanding? If I take 1 liter of water, if this 1 liter of water has less than 5 grams of dissolved substance, I call them as what? Fresh water. If this 1 liter of water has more than 30 grams of dissolved substance, approximately, I call them as what? Salt water or saline water, right? My dear friends, average ocean water salinity, if I take it, it is somewhere around 35 parts per thousand. 35 parts per thousand. 1%, see, 1 followed by 20. How you write 100, right? That is percentage. How you write 1000, 1 followed by 30. This is a symbolic representation for putting this parts per thousand. Okay. So what is my idea? Whichever water body has more than 30 grams of dissolved substance for 1000 liter or which has more than 30 parts per thousand, you call them as what? Saline water. Less than 5 parts per thousand, you call them as what? Fresh water. My dear friends, the river is a fresh water. I agree. The river is a fresh water. But I should understand that even the river, which is a fresh water, is also having what? Some salt. So river carries the salt, deposits the salt. Only water will evaporate. Again, precipitation. River further carries the salt, right? Adds the salt to the ocean. Only the water will evaporate. So what happens every time when the salt gets added, when the river water gets added with the ocean, right? With the ocean, the salinity profile will increase. Remember, somewhere we had an ocean called as Panthalassa. Panthalassa was more like a fresh water. Tethys Sea was more like a brackish water. And today, the ocean water is saline water. Okay, so gradation cycle played a very important role in somewhere increasing the salinity of the ocean. Gradation cycle, rivers. Then even submarine volcanic activity also played a very, very important role. Submarine volcanoes. Biochemical changes, the excreta of aquatic organisms, the decomposition of the dead remains of the aquatic organisms. All this can add salt to the oceans. Okay, plenty of sources are there, but the most important source is river. In spite of the fact river is a fresh water, I'm again putting a point that that's a major source which has made ocean water as saline. So as of today, if you ask me what is the average ocean water salinity today, the average ocean water salinity stands at 35 parts per thousand. It means randomly if I take 1 liter of water, seawater, randomly, if I evaporate all the waters, 1 liter of water, if I evaporate, I'll be having 35 grams of salt obtained from it. That's the idea. Okay. Right, my dear friends. So what is salinity? We have an idea. And see, the salinity will differ from place to place and time to time. But before talking about this salinity difference, we'll talk about some of the very important hypersaline water bodies of the world. We'll talk about the hypersaline water bodies of the world, my dear friends. We have waters like Lake Van, right? Lake Van in Turkey. Lake Van in Turkey, see the beauty, 330 parts per thousand. It means 1 liter of water if I just take it. 1 liter of water if I just take it. In that, 330 grams of salt will be there. It means one third of the water will be salt, right? Highly saline. And these values are not static. They'll be changing from season to season and time to time. Dead Sea. Israel-Jordan border, Dead Sea, my dear friends, nearly 240, one-fourth of the water is salt. Then Great Salt Lake of USA. They are some of the very important hypersaline water bodies of the world. Similarly, my dear friends, and one more thing, if you ask me, all these hypersaline water bodies of the world, what is common to them, if you ask me, what is common, right? They have one thing in commonality. They belong to either arid or semi-arid region. The same logic is also applicable to India. Somewhere, if I'm just looking for India, where exactly I may find it, either I'll be finding it in Rajasthan or I'll be finding it in what? Ladakh. Okay. So these are the places where exactly I may find it, because these are the places where I have a desert. In that way, the most saline water body in India is identified in Rajasthan. The name of this lake is Sambar Lake. Sambar Lake is a very important lake, right? The most saline water body in, right? Say for example, in India. Then some of the lakes, Pangong So, again and again it was there in news, my difference. Pangong So, So Moriri or Morari, right? Morari, that's how it is given in your atlas. Salt Lake, all these lakes are confined to what? Ladakh. See, the word Salt Lake is very common. Kolkata, there is also a place called a Salt Lake, right? So plenty of places you will be finding Salt Lake. But Ladakh also we have one Salt Lake. So the Salt Lake as a word, don't take it very seriously. But Pangong So and So Morari, we can take it, right? These are some of the inland saline water bodies in India. And my difference is salinity will differ from place to place and time to time. We call them as what? The distribution of salinity. What regulates this ocean water salinity is very simple. See, what is the average ocean water salinity? Somewhere I said average ocean water salinity stands at 35 parts per thousand. Okay, 35 parts per thousand. Now, everywhere I'll not have this 35 parts per thousand. Few places I'll be having very high, few places I'll be having very low salinity. So, what are the factors that determines this average salinity distribution, if you ask me? Simple. It is all about addition of fresh water versus removal of fresh water. It is all about addition. If you add more fresh water, salinity will decrease. If you remove more fresh water, salinity will increase. What is the removal mechanism? Evaporation. Temperature based, right one. What are the different ways of adding it? Precipitation directly, reverse indirectly, glacier further indirect. Am I right? So somewhere, my dear friends, all the factors what I have taken here, you will find that these, say for example, factors talks about either adding the fresh water or removing the fresh water. For example, prevailing temperature. If temperature is more fresh water will be removed. Precipitation amount. If precipitation amount is more amount of fresh water will be added. Ocean currents. How come ocean current? Very simple. Because I have warm ocean currents, I have cold ocean currents. Warm ocean current is known for inducing what? Wet condition. Cold ocean currents is inducing for what? Inducing dry condition. Already we have taken. Any desert you take it, cold currents, dry condition. So wherever I have the influence of a cold current, there all I'll be having high salinity. Wherever I have the influence of warm current, there all I'll be having low salinity. See, normally when I write this, you'll be having one small doubt. What is this? Warm current means temperature more. Temperature more means more, say for example, evaporation. If evaporation is more means salinity should increase, but you are writing decreasing. My dear friends, one connecting link you are missing it. Till when you said temperature is more, evaporation is more, you're right. But I should also understand, more than evaporation, it is compensated or overcompensated by precipitation. Because whenever I have a low pressure that is being developed in the oceanic region, that will be inducing more precipitation. Correct? That will be inducing more precipitation, my friends. That's the reason I said warm currents. What is the best way to remember? Warm current is known for inducing wet condition. If you are forgetting, always remember any desert you take it, deserts are associated with what? Cold condition or cold currents. Cold current is known for inducing dry condition. Dry condition means more sunlight. That's it. Continentality. Because water maintains the temperature, land has an influence, right, over this water. If any water body is more surrounded by land, that water body will behave more like a land itself. Okay. See, depending upon the latitude, either these continental waters can be warm or right or cold. It depends on the latitude. But continentality also matters. Even the influx of fresh water, more of rivers that is, say for example, confluencing, more water from the melting of glaciers if it is confluencing. That also will determine what? Ocean water salinity. In that way, I'm giving you some very important facts regarding this ocean water salinity. For example, latitudinally, if you ask me, where exactly you have the highest salinity? Highest salinity is tropical. Then you may be wondering, what is this not equatorial region? No, because equatorial region already we said, because equatorial region is the wettest climate in the world. You remember? Okay. Okay. So when I talk about this equatorial region, I said wettest climate in the world. Okay. So if that is the case, I understand equatorial region is more like what? A water surplus region as such. It is a water surplus region, right? Whereas the lowest salinity is associated with what? Subpolar waters. That I can agree. That I can understand. But here, this fact is very important. The highest salinity is there in what? Tropical waters, not in equatorial waters. Okay. Fact number one. And number two, among all the connected water bodies of the world, maybe I am just taking the influence of the continentality, where exactly I have, say, for example, the highest salinity, if you ask me, highest salinity is associated with the Red Sea. It's a very important fact. Among all the water bodies of the world, the highest salinity is associated with what? Red Sea, right? And the lowest salinity, my dear friends, it is Baltic Sea. Both the facts are very important. Highest salinity among the connected water bodies of the world, but marginal water bodies, Red Sea is the most saline water body in the world among the connected water bodies. I'm not talking about water bodies which is not connected like Lake Van, Dead Sea and all. Okay, right. So Red Sea is very important. And of course, the lowest salinity is associated with what? Baltic Sea. Right, my dear friends. So this is all about ocean water salinity. Okay. Right. So I have also given you the vertical distribution of ocean water salinity. See here, the concept is very simple. As you increase the depth in the ocean, the density will increase. Right. That's the only fact. What you can take it. Okay. Now, coming two more topics are very important. Right. Slightly I'll rush it up. Ocean currents, my friends. See, ocean currents. The name itself says current. The large scale continuous movement of this ocean water in a particular direction and for a sustained period, you call them as what? Ocean currents. This ocean currents, you find it happening in the surface as well as subsurface. Subsurface currents, you call them as thermohaline circulation. It's a very slow current, very sluggish current, right? Sluggish current in the sense this cycle takes hundreds of years to complete one, right? Some of the book says thousands of years, but somewhere I'm just saying hundreds, few hundreds can also make thousands. Okay, it's a very sluggish current, slow moving current. The subsurface current is all about. Okay, water can rise, water can down. Right. Now, on the other hand, what is very practical, what plays a very important role in determining the climate of the place, right, is this surface current by difference. You call them as what? Gyre circulation. This gyre circulation, right? All this currents, what you see here, any atlas randomly you take it, whatever you see here, this is what you call them as what? Gyre circulation. And my difference is gyre circulation or this surface currents. You can either classify them on temperature or you can classify them on what? The location. If you classify them on temperature, my dear friends, you call them as warm current and cold current. See, you do not have any temperature that is determining this cold and warm currents. If this water is warmer than the adjoining water, you call them as what? Warm current. If this water is colder than the adjoining water, you call them as what? Cold current. Okay, that's the only, say for example, difference we have. Okay. Now see, one more thing also you can find. Any warm current you find it, right? From this map, if I just take it, any warm current you take it. Normally you will be finding that these warm current either they come from the lower latitude, right? Or they are there in the lower latitude itself, or you can take it. Gulf Stream, where exactly it is coming from? It is coming from lower latitude. Brazilian current is coming from lower latitude. Ahula's current is coming from lower latitude. East Australian current is coming from lower latitude. Kuroshio current is coming from what? Lower latitude. So any warm current you take it, they come from warmer latitudes. Similarly, cold current comes from colder latitudes. This is one very important observation. See, lower latitudes will be warmer. So the water which is coming from the lower latitude will be warm. Higher latitudes will be colder. So the water which is coming from the higher latitude will be cold. That's what the normal idea is all about. Okay, right, fine. And what is this location? Based on location also you can classify them. If it is running along the coastline, you call them as boundary current. If it is running across the coastline, you call them as what? Open current. And my difference is boundary current is very, very important. Because what determines the climate of a particular place is this boundary current. Boundary current is very, very important. Okay. Right, my difference. Now, some of the very important observations we have to take it. And all this PDF also I'll just try to say, for example, upload it. So that some of the facts, some of the discussions, maybe my own images obstructing the view. Okay. So once the file, if it is available, somewhere you can refer it also. Okay. In that way, my dear friends. Somewhere I told you, right? Trenches. Trenches are very easy to remember because trenches are normally named, right? Normally named after the coastline, right? Current is no exception. Currents are also normally, they are also named after the coastlines, right? For example, Gulf Stream. Why exactly it is called as Gulf Stream, if you ask me? Because Gulf of Mexico. Norwegian current because of the coastline of Norway or Norwegian Sea. Canary current, one island called as Canary current. Brazil, along the coast of Brazil. Mozambique current is also called as Ahula's current. Mozambique Channel. Western side of Australia, West Australian current. Eastern side of Australia, East Australian current, and so on. Okay. So remembering the current should not be a problem. Now, my dear friends, of course, we'll be talking about the major factors which influence the currents, right? But generally, when I talk about this current, one commonality you find, any oceans you take it, randomly you take any ocean, you find one commonality. What is that commonality? Already I said, western side of the ocean will be warm and eastern side of the ocean will be cold. But we do have an exception. What is that exception? If you're there in higher latitudes, if you're there in temperate region, only northern hemisphere, Atlantic and Pacific is an example, right? Exception. If you're there in, say, for example, temperate latitudes, one small difference you experience. If you're there in temperate latitudes, it is vice versa. The western side, what you have is cold, and eastern side, what you have is warm. This is an exception, right? If I'm not mentioning this exception, largely any ocean you take it, western side of the ocean is what? Warm. And what are the various factors which, say, for example, results in the formation of the current and sustenance of the current, if you ask me? First and foremost, rotation of the earth. Rotation of the earth is the one, my dear friends, which normally results in the movement of north equatorial current and south equatorial current. And Coriolis effectivity, any moving unstable mass coming under the influence of Coriolis effectivity will get deflected towards the right in northern hemisphere and left in southern hemisphere. I mean, that's the reason somewhere the gyre circulation, if you take it for your reference, you'll be finding if you're there in northern hemisphere, the kind of circulation will be clockwise, right? Clockwise. If you're there in southern hemisphere, it will be counterclockwise. It is all because of Coriolis effectivity. Coriolis effectivity plays a very, very important role. Okay. Then even shoreline barrier. Why exactly this north equatorial current is becoming Gulf Stream? South equatorial current is becoming Brazilian current and Mozambique channel, if you ask me. It's all because of the shape of the coastline. Okay. Shape of the coastline also plays a very, very important role. Then convergence. See, this question was asked, that's the reason somewhere I'm just giving emphasis. When north and south equatorial current converges along the coastline, part of this current will be retracing its back to the original location. The current we call them as what? Counter equatorial current. So the convergence has also resulted in this counter equatorial current. Prevailing winds play a very important role. Whenever you come across the word called as drift associated with the current, drift is a wind carried movement of the water. Then temperature, particularly when I talk about thermohaline circulation, the name itself says thermohaline circulation, right? Thermo means temperature, haline means salinity. Temperature and salinity put together what determines what density. So one thing I understand, What are the various factors which influence or regulates the current? Plenty, many. That's what I should take it. But according to UPSC's previous years, the question paper analysis, one word I can leave it, that is revolution. Because UPSC has denied this revolution is resulting in what ocean currents. See, we can sit and debate on it, but always the insight comes with analyzing the past year's question. Going by that, UPSC has somewhere said that okay, revolution is not playing much role in what determining what the ocean currents. Okay, right. And my difference, wherever this ocean currents, warm and cold ocean currents meets each other, wherever there is a strong upwelling zones, that region also becomes a very important fishing grounds of the world. Okay, right, my difference. With that, some of the questions that is asked in the past, you try by yourself. Okay, try answering it. And with that, coming to the last topic of our discussion. Already we have overshooted the 2 hours of time, but still okay. 10 minutes we'll try to complete it. Tides. See the image what you're seeing. One, say for example, where the boats launches, yachts, or somewhere parked in the land, somewhere water is not there. Another is full of water. But actually, the approximate time difference between these two images, what has been shot, I prefer it is approximately 6 hours. So somewhere I understand. Once in 6 hours, you'll be finding a noticeable change that takes place. Once in 6 hours, my dear friends, the level of the water will be rising and the level of the water will be receding. When the level of the water rises, you call them as what? High tide. And when the level of the water recedes, you call them as what? Low tide. Now the question is that why exactly the water level is rising? And one more thing, see, for example, if water can maintain a level, then what is the meaning? Say, for example, every time we use this word, what is what? Mean sea level. Okay. Water can maintain a level. Why should I use this word? What does mean? Means what? Average. Right. See, different types of calculating the average is there. Mean, median, mode. Mean is more like an arithmetic average. Okay. Because the level of the sea changes every day, we use this word what does mean. Correct? Now, why exactly the level of the sea is changing? It is all because of what? The gravitational attraction induced either by moon or sun on the surface of the earth. Whenever the moon or sun comes over a particular place, the moon or sun will start pulling the water towards it. So the water level will rise. You call them as what? High tide. Okay. You call them as what? High tide. Similarly, my dear friends, when talk about, say, for example, wherever a high tide is created, Earth, in order to maintain the equilibrium, exactly the antipodal location, exactly opposite side of the Earth, will also experience one equal high tide. So that the equilibrium of the Earth is what maintained. So at any given point of time, two locations in the world will experience high tide. One because of gravitational force, another because of what? Centrifugal force. And two other places, always there is a compensation. If one place, if I have a surplus, another place I'll be having a deficit. If two places experience a high tide, two other places will experience what? Low tide. Okay. So whenever the level of the water rises, high tide, so what happens? The water will start moving towards the coastal area. You call them as the current, you call them as flood current. And whenever the level of the water recedes, it becomes more like a low tide. The water level will start moving towards what? Peak sea as such. All the water which has entered, the land will be start moving towards it. So every time, right, you'll be finding a noticeable to and fro of water. Sometimes you go to a beach, you'll be finding that sea is very close to you. Sometimes you go to the same beach, you'll be finding sea is far away from you. When it is far away from you, it means you have gone through during what? Low tide. If it is very close to you, it means you can take it for granted that you have visited the sea during what? High tide as a time. Okay, right. So what is a tide? The rise and fall of the sea level due to the gravitational attraction induced either by moon or sun. You call them as what? Tide. Right? Tide. So what is a tide? See, wave is different, tide is different. Tide can be created by sun. Tide can be created by moon. Right? Both can create tide. But what is very important is what? Lunar tide. Lunar tide is at least twice more than that of a solar tide. Why? Because moon is very close to Earth as such. In that way, my difference in one lunar day means approximately on an average today's moon rise to tomorrow's moon rise. On an average, I'm saying 24 hours and 52 minutes. It means 24 hours and 52 minutes. I'll be having two high tide and two low tide that one place will be located or one place will experience. It means the time difference between two successive high tide will be somewhere around 12 hours and 26 minutes. And time difference between one high tide and one low tide will be 6 hours and 13 minutes. It means every 6 hours and 13 minutes, the level of the water will rise and the level of the water will recede. But what is very practical? What is very practical is a mixed tide, my dear friends. When I say mixed tide, it is not only sun or moon, right? In isolation, they are creating a tide. No, they are creating a tide together. In that way, when sun, moon, and earth all comes in a straight line, for example, assume that okay, this earth, above you're standing at a place above your head, exactly above your head, you have a moon, and exactly above the moon, right? Maybe sun can be there, or sun cannot be there, may not be there. Whatever it is the possible, right? Whatever this way, I'm just taking it. So wherever all this three celestial body comes in a straight line, so what happens, for example, take this case for example, right? This is the place where a high tide is created not only by moon, but also by sun. So one lunar high tide is also created. Along with that, one solar high tide is also created. It means on this occasion, the high tide created will be highest. The high tide created is highest. The low tide created will be lowest. So the tidal range on this day will be maximum. And this tide is what we call them as what spring tide, my dear friends. Sea will be very rough on that day because the rise and fall of the water will be very, very high during what? That day. So this spring tide can either occur on a new moon day or a full moon day. Okay. See, these are the days when eclipse will also take place. New moon day is that day when solar eclipse will take place. Full moon day is the day when lunar eclipse will take place. That's okay. That's a different story. But the mixed tide, Sisgi, right, or a spring tide will happen either on a new moon day or a full moon day. On the other hand, see, this is a time when both are complementing each other. Same place, sun is also creating a high tide, moon is also creating a high tide. But we have one more tide, you call them as what? Neap tide. Exactly opposite. The place where exactly high tide is created by moon, sun creates a low tide. Earlier case, what happens? High tide is created by moon. The same place, again high tide is created by sun. So what happens? The level of the water raised, further it is raised by what? Sun. Here what is happening? High tide is created by moon, but that is the same place where the low tide is created by sun. So the water level is what? Receding here. Neap tide. So on this day, my dear friends, right? So this high tide will be low and low tide will be high. The tidal range will be what? Minimum. When exactly you experience this? On first quarter and the third quarter. Okay. Right, my dear friends. This is all about tides. This is all about tide as such. Okay. Right. Now see, I'll give you one terminology. You try to identify what exactly is the meaning of this term. Somewhere you come across something called as king tide. So kindly see or kindly somewhere, right, explore what do you mean by a king tide. See, king tide is one informal term what exactly we use nowadays, but still you try to explore what exactly is a king tide. Okay, right, my dear friends. So with this, we are just bringing this discussion to an end. At most we have taken 15 more minutes, but only thing is that the topics what I thought of covering it, we have covered it. But still, ocean currents and all slightly we're running, right, than the usual pace. Whatever it is the case, superficially we have covered it. Again, so the very basic facts, important facts we have covered it. Right, my difference. One more time, you just go through it. Whatever you feel it is important, go through it. Very limited time is there for the examination. Don't worry, but still constant revision and keep your motivation level always high. Avoid negativity. Somebody comes and talks negative to you, avoid negativity. Because confidence is the one which will make you to survive this race, right? So with that, we'll take a leave. Thank you and God bless. Rest we'll take it in the next class. Thank you.